Okay, so we're going to continue finding annihilators for functions found in the guided notes, and I think we're up to our 6th one now. All right, so for this function, we just got done finding the annihilator for the cosine of 4x, so we know how to handle the sine x if it was by itself. If it was just the sine of x, we know that d squared plus 16 would annihilate the sine of 4x. But now the question is, what do we do with the 5 and the x? Well, any multiplied constant, we can ignore it because 5 times any derivative stays the same. So we always ignore multiplied constants in front of functions when we find annihilators. But the question really does come down to what do we do with that x? So if we think about an earlier example, remember an x in front of a function signifies that there's a repeat in the root. So in this case, somebody solved an equation and they got r is equal to plus or minus 4i, and it was repeated, so therefore they had to put an x in front of it. So to model that repeat, we actually put a square on this operator, and that will then annihilate this function. And again, it's a very tedious process because if you actually square this out, that's a fourth derivative and a product rule. So that'd be the product rule 4 times over, which we don't want to do. But the idea is that if you were to apply this annihilator to that function, it would make 0 for our final answer. So the annihilator is d squared plus 16 squared. All right, so next up, let's take a look at the product of an exponential function with a trig function. So let's take a look at e to the 2x times the cosine of 3x. Again, we have to kind of think about differential equations in reverse. If we were to solve this and get to this answer, this would come from an r is 2 plus or minus 3i, because the 2 again turns into the exponent on the exponential, and the imaginary part turns into the coefficient on the variable inside the trig function. So working backwards and completing the square, this is the same thing as r minus 2 is equal to plus or minus 3i. Then if we square both sides, that's r minus 2 squared equals plus or minus 3i squared, which is plus, well, actually there's no plus or minus anymore when you square it, it's just positive. That would be 9i squared, which would just be negative 9. And then if we add the 9 over, that's r minus 2 squared plus 9. So that right there would be our solution of our auxiliary equation, and that translates over into our annihilator. Our annihilator would be d minus 2 squared plus 9. So what we're saying here is if you were to take the operation of d minus 2 twice and then add on 9 times the function, you would get 0 for an answer. So our annihilator is d minus 2 squared plus 9. And again, you could actually prove this formally by just applying this annihilator to that function and getting 0 for an answer. For the next one, we have a similar example. It's f of x is equal to an e to the negative x times now the sine of 3x. So let's just write down the annihilator without going through the explanation for it. If you think about the previous example, the coefficient on the exponential, we always take the opposite of it. So that's a d plus 1 that we're going to apply. And then to annihilate the sine of 3x, we add on a 9. So that operator, or annihilator if you will, is d plus 1 squared plus 9. And again, these are all checkable. All you have to do is just take this operator and apply it to that function, and it will annihilate and give you 0 for an answer.